Hello, and welcome to this lesson on solving equations with variables on both sides. So this is a continuation of the previous lesson where we were solving multi-step equations. But if you'll remember in that lesson, we skipped step 3 in the steps of solving an equation. And I said at the time, step 3 was what happens when you have variables on both sides. Well, that's what this lesson is all about. So we were going to work on all 5 steps of solving equations, and so this will actually be a lot more practice of the previous lesson, plus this one new skill. So you can see the essential question says, how do I solve equations with variables on both sides of the equal sign? And this skill also does extend to inequalities as well, and that happens much later on. Did you know that the actual skill in this lesson is how you move a term from one side of the equal sign to the other? And that's going to happen a lot the whole year. I mean, in the pre-algebra course and in algebra and beyond, it's very essential that you're able to move something from one side of the equal sign to another. Physics and chemistry and pretty much everywhere. But while we're here, the way you move a term from one side to the other is always going to be using an addition or a subtraction. And in this lesson, we will get our first problems that don't have a solution, where we're actually going to say there is no answer to this problem. And that can happen sometimes. That's going to actually happen periodically throughout the different units. So, first thing we got here is our 5 steps of solving an equation. The last lesson, we did steps 1, 2, 4, and 5, so let's get them all. Those first 4 are all going to be the same. So step 1 is we get rid of the variable, we get rid of parentheses using the distributive property. Get rid of parentheses by distributing. Our second step is going to be we combine like terms. On each side of the equal sign. Our new step 3 is what happens if we have variables, the same variable on both sides of the equal sign. We are going to get rid of the variable on the right. Now, I will preface by saying there is no rule that says it has to be on the right. So I said yesterday that these steps aren't like set in stone, like you have to do exactly this. This is the method that will give you the easiest method of solving an equation most of the time. And that's true here as well. This idea of getting rid of the variable on the right, if you've got variables on both sides, it's just to make your life easier most of the time. And we'll talk about that. We'll see examples of that. The last 2 steps are the same. We're going to get rid of addition and subtraction. And subtract by doing the opposite. And then finally, we get rid of the multiplies and divides. Multiply and divide. So now we have all 5 steps of solving an equation. So let's see how this is used in practice. You'll notice that these equations are a bit bigger, a bit uglier. There's more stuff. So if we look at example A here. So if you're a fan of the line down the equal sign, you can do that. So I'm going through those 5 steps in my head, and you can refer back to them if you need to. First step was get rid of parentheses. There are none. Second step is combine like terms on each side. So on this left side here, why do I have a big glowy circle? On this left side here, I'm sorry, on the right side, I do not have like terms. I have a k and a non-k, so those are not alike. On the actual left side, these are not like terms. I've got a k and a non-k. So on each side, I don't have like terms. Step 3, get rid of the variable on the right. So you'll see I have a 14k and an 11k. They're on different sides of the equal sign. We're going to get rid of the one on the right. And we'll talk about why that's a good idea. Most of you prefer to have the variable when you're solving on this left-hand side. So if we get rid of the one on the right, the variable will always be on what we think of as the correct side. And it's just kind of more of a comfort thing. Now, the way we're going to get rid of the 11k is it's always using addition subtraction. To move something from one side of the equal sign to the other, it's addition and subtraction. So I want to make this go away. Since it is a positive 11k, I am going to subtract it or use a negative. Positive 11k and negative 11k equals 0. And that piece is now gone. I would only have a 94 left on the right-hand side. When I subtract 11k on the other side, you'll notice I lined him up with his like term, k's and k's. So now I'm going to do 14k minus 11k gives me 3k. 14 minus 11 is 3. And there's the rest of the equation. Now, what we have left is very familiar to what we've been doing in the previous lesson. This is a two-step equation. We're going to get rid of the addition-subtraction piece first. That's him. By subtracting 55. And if I'm going too fast for you, you might want to refer back to the previous lesson if you're not quite sure why I'm doing the steps I'm doing. Or you can always pause the video and try the problem yourself. 94 minus 55, I'm not confident in my head math, so I'm going to type it out. It is 39. And then finally, the last step to solve this equation is we're going to divide by 3 to cancel out this multiply by 3. And when I divide by 3 on both sides, I get the solution k equals 13. I am confident of that head math. So there's the whole problem. It was bigger and uglier, but it wasn't that bad. We got rid of the variable on the right-hand side using addition or subtraction. So we subtracted 11 because it was a positive 11. We then had a two-step equation. We got rid of the addition-subtraction piece. We're trying to get the variable by itself. So I subtracted 55 on both sides. We then had 3k equals 39. To get rid of that, multiply by 3. We divided by 3 on both sides, and k equals 13. Letter B. So looking at this problem, we do have parentheses. So that's going to be my first step, is I'm going to distribute to get rid of those parentheses. So we're going to get 2m plus 10. Please make sure you did multiply by this. It's 2 times 5. You don't just bring the 5 down. That's probably the most common mistake with distributive property that I see. On the other side, 4m plus 17. So now we're in the same place we were at the beginning of the previous problem. I don't have any more parentheses. I don't have any like terms to combine on either side. Nothing here combines. Nothing on the left combines. So I'm going to get rid of the variable on the right. So I'm going to subtract 4m because I want to cancel out this positive 4m. So I'm going to have, let's see, negative 2m. That is 2m minus 4. 2 minus 4 is negative 2. Plus 10 equals 17. I keep going. I'm solving the equation. So I'm going to subtract 10 on both sides. I'm getting rid of the add and subtract before this multiply. Subtract 10 on both sides, and negative 2m equals 7. Lastly, I'm going to divide by negative 2. I'm trying to cancel out the multiply by negative 2. M equals 7 divided by negative 2 is negative 3.5, or 3.5 if you did fraction, negative 3 1/2. So negative 7 divided by 2 is negative 3.5. So either one of those is fine if you went the fraction way or the decimal way. And there we have it. Again, not too terrible overall. We distributed. We got rid of the variable on the right. We got rid of add and subtract. We canceled out the multiply using divide, and we're done. Now, I'm going to erase this. I'm going to show you what happens if you get rid of the variable on the left. So the rule we had, or the rule we set up above, was get rid of the variable on the right. What happens if we don't follow that rule? The honest answer is nothing too bad is going to happen. So there's my distributing. I kept the distribute. That would still be the first step. Now, if I get rid of the variable on the left, I'm going to subtract 2m. He's a positive. I get rid of it using subtraction. 10 and 2m plus 17. Now, if my goal is to get the variable by itself, I'm not going to get rid of this 10. I'm not going to minus 10. I'm going to get rid of the stuff on the same side of the equal sign as the variable. So we get rid of addition and subtraction first, multiplies and divides last. So I'm going to get rid of this plus 17. Minus 17, 2m equals negative 7. And then finally, to get rid of that multiply by 2, we are going to divide by 2 on both sides, and m equals the same, negative 3.5. So we got the same answer. The only difference is, instead of having, after we kind of got rid of one of the variables, instead of having the variable on the right hand or the left hand side where most people prefer it, our m was on the right hand side. And I know some people do not like that. So that's why the rule is there of getting rid of the variable on the right. You have a choice, but most people prefer to get rid of the variable on the right. So there's both problems again if you need to check over anything. All right, letters C and D. Letter C doesn't look too bad. Letter D looks a little ugly. I see lots of parentheses and distributing that's going to be needed. So let's work on letter C first. So there's my line down the equal sign. So I don't see any parentheses. I don't see any like terms. So I'm going to start by getting rid of the variable on the right. I want to get rid of this guy. So I'm going to add 10, and he is a minus 10. I get rid of him using a plus 10, and always on both sides. So what does that give us? Well, negative 7 plus 10 is going to be a 3. Negative 7 plus 10 is positive 3n. That circle's a little big for me. There we go. And now it's just a two-step equation. I'm going to get, sorry, I dropped my pencil. We're going to get the variable by itself, so I'm going to get rid of this minus 5 using a plus 5 on both sides. 3n equals 18. Divide by 3 on both sides to cancel out the multiply by 3. N equals 6. Hopefully by now you're able to kind of keep pace and understand what we're doing. I would even encourage you, maybe before I do a problem, see if you can do it on your own. See if you can work ahead of me and see if you're getting the right answer before I go through it. And then if you didn't get the right answer, all you gotta do is look for where did your mistake happen. That's where the best learning comes in. Letter D, I mean, if you're looking for a challenge, try it. Feel free to pause the video and try this problem before me. If not, well, let's get through it. So I see here I've got parentheses on both sides. I'm going to have to distribute on both sides. Let's do the right-hand side first because it's a little bit easier, a little bit prettier. So 5 times n is 5n. 5 times 2 is 10. Okay, that's the pretty side. Ugly side, which actually isn't as ugly as it looks. We are going to have to take the fraction 3/5 times by 5 and 3/5 times by 10n. Now, if you have a handy-dandy calculator, you can just type in 3 fraction 5, get out of the fraction, 3/5 times 5 equals 3. So 3/5 times 5 was just plain old 3. If you don't have a handy-dandy calculator, you can multiply by hand, and you multiply across the top is 30, multiply across the bottom is 5. 30 over 5 as a fraction, 30 over 5 simplifies down to just 6. So that is 6n. And my stuff's not really lined up, so let's fix that. There we go. So you can multiply by hand, or you can multiply by calculator. Now, if we continue to solve here, I'm looking, so we got rid of our parentheses. I cannot combine anything on the right. I cannot combine anything on the left. So then we move on to getting the variable by itself. So I'm going to move the variable. I'm going to get rid of the variable on the left, or on the right-hand side. I'm going to move it to the left. So we subtract 5n on both sides. Now we have 10 equals, that is 3 plus 5 minus 6, 6 minus 5 is 1n. And I don't really actually need that one. I'm going to make it a ghost. Ooh, my goodness, my highlighter's huge. I'm going to make it a ghost one. We don't really need the one there. It's not doing a major job there. At the end, I would divide by 1 possibly, but that wouldn't really change the answer. So I'm going to put it as a ghost one. We solve. To get rid of the addition-subtraction piece, I'm going to subtract 3 on both sides. And now we're going to have n, or 1n, equals 7. I can stop here. I don't need to divide by 1. I don't need to get rid of this 1 in front of a variable. Anytime you see a variable by itself, like that, that is 1n. We don't have to get rid of the 1. So I'm going to stop right here and say you are done. And if we want to pretty it up and get rid of the ghost 1, we can do that too. So it looked ugly, but it wasn't that bad. So there's letters C and D. If you want to check over anything or pause the video and make sure you got it. So I've done 4 problems now. It is time for you to try a few. So on the screen here, we have letters E and F. Please pause the video, try them on your own. When you're ready to go through them together, or if you get stuck, hit play, and we will go through it together. All right, so letter E. Let's see. I'm going to stop putting the line down the equal sign because for the most part, it's just not something I usually do a whole lot of. It's a nice trick when you're first learning to solve equations to help you recognize the 2 sides of the equal sign. But as you can become more familiar, it becomes less common. So I'm looking at both sides of my equal sign. There's no parentheses. I can't combine anything. So I'm going to subtract 7k to get rid of this plus 7k on both sides. That gives me negative 2k. That's 5 minus 7 is negative 2. Minus 8 equals 13. Now, my next step is I can either get rid of this times by -2 or this -8. And we get rid of additions and subtractions first. So I'm going to add 8 to both sides. -2k equals 21 should be. And then finally, when we divide by -2 on both sides, we're going to get k equals -10.5, or the fraction 10.5. Let me double check it. Pretty sure I'm right, but I'd hate to make a dumb mistake, and I could check it. There we go. So k equals -10.5, or 10.5. Ooh. Okay. Letter F. So there's no parentheses, there's no combining like terms. I do have variables on both sides. I have a b on the left and the right. So we're going to get rid of the one on the right. I'm going to add 8b to cancel out that -8b. We have 6b, that is the -2 plus 8 is +6, plus 9 equals a -9. Don't forget about that sign. I know a lot of folks, when you drop this piece, we kind of forget about that negative sign. We think that, oh, since there's nothing to minus, that minus goes away. No, that's not really true. That minus sign is connected to the number 9. They're paired together, just like this negative and this 2 are paired together. So when this -8b goes away, I still have a -9, a -9. Okay, so make sure you keep that sign. From there, I'm going to continue solving. So I'm on the next step, I'm going to subtract 9 to get rid of my +9 on both sides. 6b equals a -18. And then finally, when I divide by 6 on both sides, b equals -3. So there's letter F for you. And there's both of them for you. All right, here's a couple more. So they're getting a little bit bigger. There's more parentheses. There's more steps. Pause the video. Try it on your own. When you're ready to continue, hit play, and we will go through it together. All right, so let's check out letter G. So I'm going to start by distributing 3h plus 15. Make sure you have that as a 15, not a 5. I have variables on both sides. I'm going to get rid of the one on the right. So I'm going to subtract 3h on both sides. And then h minus 3h is going to be a 2h. To continue solving our equation, I'm going to subtract 5 on both sides to cancel out that plus 5. 2h equals 10. And then finally, last step, divide by 2 on both sides, and h equals 5. So there's the whole letter G. Letter H. I have parentheses. I'm going to distribute. You can multiply by hand or multiply by calculator. I know that half of -8, just 1/2 of -8. Remember I said of means multiply. So half of -8 is -4. And half of a -16 is a -8. No calculator needed if you got a good brain on you. Okay, now I am going to get rid of the variable on the right-hand side. I looked for like terms. There were none. So I'm going to add 7c to cancel out that minus. Let's see, -4c plus 7c. -4 plus 7 is a +3. And we're now down to a 2-step equation. So we've had 4 steps to solve this. We did distributive property. We got rid of the variable on the right. Now we're going to get rid of add and subtract, and then followed by get rid of the multiply and divide. So we're going to add 8 on both sides. 3c equals 24. And then finally, when you divide by 3 on both sides, to get rid of the multiply by 3 that was there, c equals 8. And there's your letter H. And there's both of them. Okay, they look kind of the same, bigger, uglier. Let's see what happens. So these types of problems are going to be solving an equation without a solution. Now, you're looking at them and go, well, they don't really look that much different. And you're right. And you're not really going to know just by looking at an equation from the beginning of the problem whether it has a solution or not. The only way you're going to figure this out is when you actually start solving it. So we start solving. I'm going to distribute here. Oops, there we go. We have negative 10x plus 5 equals negative 10x plus 2. We continue solving. Now, you may see that when I add 10x to get rid of my variable on the right, and I add 10x to the left, both of my variables cancel out. I have no more x's left in this problem. This is a 0. Negative 10 plus 10, 0. Negative 10x plus 10x, 0. So I'm not going to put an x down here. That's probably the biggest mistake I see students make in this type of problem. There is no more x left. The x's are gone. What we have left is a 5 and a 2. This 5 and this 2. So we got 5 equals 2. Now there are two different types of, I call them special solutions, two different types of special solutions you can get once your variable completely cancels out like we have here. You can get an answer of all real numbers Sometimes this, you'll also hear people say this has infinitely many solutions. These two words are sort of interchangeable. The two phrases are sort of interchangeable, but they have slightly different meanings. So that's one possibility. The other possibility is no solution. And we have to decide the problem that we just solved, which of these it is. Is there an infinite number of answers? Is every single number an answer to this problem? Or is there no answer? And the way you figure that out is you look at this statement. When your variable's completely canceled out, we have 5 equals 2. 5 equals 2. So you ask yourself, is that true? Does 5 equal 2? If the answer is no, then we get no solution. If the answer is yes, then we'd say we have all real numbers or possibly infinitely many solutions. So in this problem, 5 equals 2? No. 5 does not equal 2. That's false. That's not true at all. So this problem has no solution. That's the answer to the problem. No solution. Not 5 equals 2. 5 equals 2 is just kind of like the evidence for our answer. But this problem has no solution. And the reason why this problem has no solution is we're saying there is not a single number you can plug in for x in the original problem and have the two sides equal. Not 0, not -5, not +3, nothing. And I can kind of show that using this step right here. So this step right here, so after I've distributed, look at these two sides. Make this bigger. The negative 10x here and the negative 10x here are the same. So let's think about it. Let's imagine you pick some random number in your head, say x equals 2. If you plugged in a 2 for x on both sides, both those pieces I have highlighted in pink would have the same value. I would take negative 10 times by the 2, or whatever number you picked. Now, if you took this piece that had the same value, and on one side you added 5, but on the other side you only added 2, would these two sides have the same value? I mean, this would be negative 20 plus 5. Negative 20 plus 5 is negative 15. On the other side, negative 20 plus 2 is negative 18. They don't have the same value. And they will never have the same value, no matter what number you plug in for x, because again, this pink piece has the same value. On one side you add 5, the other side you add 2, it's just not going to work out. So that's kind of the reasoning why we say this problem has no solution. I'm going to put some of the math back. Okay, so we added 10x, added 10x. This guy's gone, this guy's gone. There we go. Okay, so this problem had no solution because not a single number will ever make this equation true. Because when our variables canceled out on both sides, the resulting equation is not true. Okay, let's move on. Letter B. Line. I said I wasn't going to do it anymore. I lied. I did it. Distribute. Boom, boom. Negative 8 plus 12x equals 12x minus 8. You may look at that and recognize that both sides of my equal sign are nearly identical. I have a negative 8 over here and negative 8 over there. A positive 12 on the left, a positive 12 on the right. I could actually stop the problem right here and tell you what the answer is, but we're going to continue one more step. I like to go until I've eliminated my variables. So I'm going to subtract 12x to cancel out the variable on the right. And when I do it on both sides, it also cancels out the variable on the left. I have no more x's left. I have negative 8 equals negative 8. And so you ask yourself, is that true? Does negative 8 equal negative 8? Well, yes. So this problem has lots of answers. It has, well, this phrase here, all real numbers. Every single number is an answer to this problem, which means that there's an infinite number of answers. There's infinitely many solutions. Every single number is an answer because no matter what number I plug in for x in the original problem, both sides will always be the same. So we're going to say that this problem, that every single number is an answer. All real, and I like to abbreviate, numbers. This is the answer to the question. Every single number is an answer. And again, I can show from this step here, this 12x and this 12x, if I plugged a number in for x, would have the same value. If I use that same x equals 2. Okay, so now this is a 24, this is a 24. On the right-hand side, I would take 24 down minus 8. On the left-hand side, I would take that 24, and when I add a negative 8, that's the same thing as doing minus 8. Look at it. My two sides are always going to have the same value, no matter what number you plug in. So every single number is an answer to this problem. So because this fact is true, that means we have all real numbers. Okay, I'm taking a lot of time on these two problems to make sure you understand the differences between no solution and all real numbers. It takes students a little bit of time to to sort them in their brains. So I'm trying to explain in a couple different ways to hopefully make sense to you. Okay, so here's both problems again. Here's A and B. So when we move on to the next few problems, you feel free to refer back to this if you need to. Now, I'm going to start going a little bit quicker because I've droned on quite a bit so far. So distribute. 28c plus 8 equals 28c minus 5. I can tell you right now this is going to have no solution because this 28c and that 28c are going to cancel out. They're going to have the same value. If I subtract 28c here, gone. Minus 28c there, gone. I'm left with 8 equals a negative 5. Yes, he's still a negative. See? Negative 5. And this is not true. 8 does not equal negative 5, which means this problem is not going to have a solution. No solution. My variables cancel out on both sides, and the resulting equation is not true. No solution. Letter D. I'm distributing. I have 12g minus 6. I have 12g plus 6. I know this 12g and this 12g will have the same value. If I subtract 12g on both sides, I'm left with a 6 and a, here's the trick, it's still a minus 6. A lot of people, again, forget that minus sign and they put 6 equals 6, and then they say this has infinitely many solutions, or all real numbers. But this one has no solution. 6 does not equal negative 6. No solution. This is false. But you can't put false as an answer. That's just to help you understand which of the solutions it is. Is it all real numbers or no solution? No solution because the resulting equation is not true, and it will never be true. It will never work. There's never going to be an answer. There. That was quite a bit quicker. All right, so here's letters E and F of this type of problem. I would like you to pause the video, try these two on your own. When you're ready to continue, hit play, and we will go through them together. All right, letter E. Distribute 3x plus 9, 3x plus 9. You could literally stop right now. Do you see how both sides of the equal sign are 100% identical? 3x plus 9, 3x plus 9. You could stop right now and say this problem has infinitely many solutions. This problem has all real numbers. As a solution, because the two sides are identical. Because we know if we subtract 3x here and we subtract 3x here, we're going to get 9 equals 9, which is true. So if you ever have an equation where both sides are identical, 100% the same, you'll know that that actually will have a solution, and every single number will be an answer. Both sides will always be the same. Combine like terms. 8x multiply negative 8x. If we add 8x to both sides, this side gives me 0. This side gives me 16x, which is a little weird. I mean, it doesn't quite fit into the other problems we have been doing, and maybe that tricked you. Because you thought that there would be no solution or all real numbers, but this one actually does have a solution. Because, I mean, the opposite of minus 8 is plus 8. 8 plus 8 is 16. And if I divide by 16 on both sides, I'm trying to get the variable by itself, x actually equals 0. This one did have a solution. And I'm okay leaving it there. I'm okay that might have tricked you. Because you don't always know, like you're not always going to be given a problem or a problem set going, all of these problems have no solution. A lot of times it's going to say solve the equation if possible. So as you're going through and solving, you don't know if it's possible to solve. You don't know if there's going to be an answer or not until you've actually done the work. And they're going to try to trick you. Little things like this. Like you saw 8x and 8x, and you might have went, oh yeah, that's all real numbers because I have the same thing on both sides, but you didn't. Okay, so watch out for little things like that. There's E and F. Here's letters G and H. You see they're a little bit longer problems. I had to kind of stagger them down the page. Go ahead and try these two. You're ready to continue, hit play, and we will go through them together. All right, letter G. So we have distribute the parentheses. We've got 4x plus 3. On the other side, oh, no, that's not 3. I forgot to multiply. How about 6? 4x plus 6. On the left-hand side, I can combine this x and this x. 1x combined with 3x gives me 4x. And my 5 comes along for the ride. I can see that when I subtract 4x on both sides, both of those 4x's are going to cancel. And I'm going to have 5 equals 6, which is not true. So this problem has no solution. And we're done. There's letter H. All right, distribute. Negative 4x plus 20 minus 1. So I did my distributive property here. Negative 4x plus 20. And then I'm just writing down the rest of the problem. 19 minus 4x. I can combine this 20 minus 1. I can simplify that. So let's do that simplify. That gives me just 19. And I can see that when I add 4x to both sides, both my x's cancel, and I have a 19 on the left and a 19 on the right, which means this problem, no matter what you plug in for x in the original problem, both sides of the equal sign will always be the same. This is true, so my answer is all real numbers. Every single number is an answer. There's infinite number of answers. All real numbers. So there's letters G and H. All right. So we're finally down to the applications, the last few problems of this. So this one says, find the perimeter of the square with the given side lengths. So you need a little background knowledge on this. Like, we want to find the perimeter, like an actual number. Is the perimeter 5 or 9 or 37 or whatever it is? So there's a little trick here. We know, because it's a square, that all the sides are the same. I mean, this side is the same as this side, is the same as this one, is the same as this one. Well, what that allows us to do is actually set up an equation. I can say this side equals that side. 2x plus 3 equals 5x minus 9. Because the sides are the same, it's a square, they're identical, I can set them equal to each other. And now we can solve this equation. Minus 5x. Oh, by the way, it would have been just as fine if you put like the 5x over here and the 2x thingy over there. That would have been just as fine. Okay, and since I just changed it, I'm going to leave it here. I'm not going to put it back. But it would have been just as fine to have it either way. Minus 2x on both sides. This guy cancels. This gives me 3x minus 9 equals 3. Add 9 to both sides to cancel out the minus 9. I'm just solving the equation. 3x equals 12. To get rid of the multiply by 3, we divide by 3 on both sides. And finally, x equals 4. Think right now, why is 4 not the answer to this problem? 4 is not the right answer. And a lot of students would get that far and stop, and especially on a multiple choice test, I mean, I would have answers of like 4, 11, C would be 22, D would be 44. If I had a multiple choice question, those would be my 4 choices I'd give you. Every one of those is a common mistake students make. Well, except for the one that's the correct answer. So it's not 4 because 4 is x. X is 4. Not the length of the side, not the perimeter of the square, just x. That's not what it asked us to find. We want to find the perimeter of the square. So I know that x is 4. So what I can do is I can plug in 4 in for one of the x's. Check this out. 5 times 4 minus 9. I know that x is 4. We just found that out. 20 minus 9 is 11. So, is 11 my answer? Nope. 11's not the answer either. It's another trick. 11's not the answer because we're looking for the perimeter. Again, going back to the question. The perimeter of the square, not how big is each side of the square. If that was the question, we'd be done. Each side of the square is 11. And if I would have plugged in 4 for this x, here, 2 times 4 plus 3. 2 times 4 is 8, plus 3, again, is also 11. That's just how big the square is. So, what's the perimeter? Well, if you add up all the sides of a square, you should get 44. The 22 is, I have some students who they forget to add all 4 sides of the square. Like they'll just add like this side here and this side here, just the 2 that they see. Another possible answer, if there was 5 choices, would have been 121 for folks who multiplied the 11 times 11 instead of adding them all up. Okay. So this was kind of a multi-step problem. You had to, like, at each step, ask yourself, is this the right answer? Is this what the question is asking me to find? And in most of the times, the answer was no. All right, this is the last question of this lesson. It says, what is the area of a triangle if the area is represented by 3x plus 2, the base is represented by 4x minus 8, and the height of the triangle is 6. The formula for the area of a triangle is area equals 1/2 base times height. So let me do a little clarify. When it says what is the area of the triangle, don't give me back 3x plus 2. It says that it's represented by that. I want an actual number. Is the area of the triangle 5, 9, 37, something like that? Okay? So go ahead and pause the video. Try this one on your own. Do what you can. If you get stuck, pause the video, and then we'll go through it together. All right, so let's see here. What is the area of the triangle? So I'm a big fan of drawing pictures, especially in a problem that there is no picture. So I'm going to draw myself a triangle. All right. So it tells me the area of this triangle is 3x plus 2. It tells me the base of this triangle is 4x minus 8. So there's the area, there's the base. The height of the triangle is 6 inches. And then they give me the formula area for a triangle. Well, that's useful because, the first step after you've written down a formula, area equals 1/2 base times height, is to plug in what you know. Substitute. I know, right here. Area area. I'm going to plug in 3x plus 2 in for area. It tells me that that's what the area is. 1/2. Base. I'm going to plug in the base. Let me change color here. I'm going to plug in the base for the base. 4x minus 8. I'm going to plug in the height for the height. Now, what I have is a relatively ugly equation, but it's solvable using all the steps we've learned. I mean, we learned all the steps of solving an equation. We just got to combine them all together now into one, well, fairly ugly looking problem. So I'm looking on the left, 3x plus 2. There is nothing to do there. I can't combine, I can't distribute. I really pretty much have to simplify this right-hand side a whole bunch. Starting with, what I would do is I would start by distributing. Boom, boom. Let's start getting rid of some parentheses. Half of 4 is 2x. Half of 8, or half of minus 8, is minus 4. Now, I actually still need these parentheses up front here, because even though we did this distribute, we still need to take 6 times by this whole thing. So I'm going to distribute again. I'm taking the outside number multiplied by everything on the inside. I'm just kind of doing it the reverse direction this time. So we've got 12x minus 24. And that was probably the hardest part of the whole problem. So once you were able to plug your numbers in, this distributing once, distributing twice, that was honestly probably the hardest part of the whole problem, because now this is familiar. We've done lots of that. We're going to get rid of the variable on the right. So we subtract 12x on both sides. 9x plus 2 equals negative 24. Minus 2, I'm getting rid of the add and subtract on both sides. 9x equals negative 26. Now I can see in my head that this is going to give me a weird answer, so I'm just doing a quick double check to see if I made any little typos anywhere. Just because you get an ugly decimal doesn't necessarily mean you messed up, but it's always good to check. So I'm just running through the math again. Half of 4 is 2. Half of 8 is negative 4. I like. 6 times 2 is 12. 6 times 4 is minus 24. Okay. I subtract 12 on both sides. Ooh, okay. I did see one mistake, but it doesn't really fix my problem. This should be a negative 9. 3 minus 12 is negative 9. I'll carry that negative sign down here as well. And then I subtract 2. Nope, I think we're just going to get an ugly answer. All right. So I'm glad I looked back. I did fix a little mistake I made. So my next step is I'm going to divide by negative 9 on both sides. These cancel out. And I guess over here, x equals negative 26 divided by 9 is negative 2.8 repeated. So in case you don't know, your calculator, this calculator, almost all calculators round the last digit. So that's why it goes negative 2.888888889. If this could continue forever, it would keep going 88888888888 forever. But because the calculator rounds, there's an 8 here and another 8 after it, it rounded up. Okay, so be cautious of it. Understand that your calculator does it. So now you ask yourself, are we done? No. We found x. We did not find the area of the triangle. but we're only like one step away. So all we have to do is we're going to take this x value. Where's my colors? Green. We're going to take this x value that we just found, and we're going to plug it in for x in what it tells us is the formula that represents the area. Remember, it said in the problem, the area is represented by 3x plus 2. So if I knew what x was, I could just take 3 times that thing, add 2, and I got myself an answer. So we're going to do that. Area is 3x plus 2. Area is 3 times negative 2.8. I'm plugging in the x value we just found. Plus 2. Area is, calculator time, 3 times negative 2.8. Oopsie, I made a boo-boo. 3 times negative 2.8888888888. Fill your whole screen with 8s. Equals. And then we add 2, we get our final answer. Negative 6.6 repeated. Again, your calculator rounds that last digit. So this is the area, inches, of the triangle. Another hard problem, and that's okay. It's okay to have hard problems that you struggle with. Summary. How can you tell if an equation will have one solution, no solution, or all numbers as a solution? Think about it. When you're ready to continue, hit play, and then we'll go through it together. So when you're solving an equation, if you got something like x equals 5, where you still have an x, that has one solution. If you got something like, if your variable canceled out and you have 3 equals 12, that's not true. That would have no solution. And if you solved an equation and your variables completely canceled out on both sides, and you get something like negative 2 equals negative 2, that is true, that would have all real numbers as a solution. All right, so quick little recap. In this lesson, we learned the steps of solving an equation. We have all 5 steps now. We added in this new step of how to get rid of the variable on the right if you have variables on both sides. And the trick was you got rid of it using an addition or a subtraction like we did here. And then we did a whole bunch of practice problems. We then learned what it looks like if you have an equation with no solution. That is what we were just talking about. If your variable completely cancels out, I have no more x's left, then you're either going to get no solution or all real numbers. No solution is what happens if this is a false statement. All real numbers is what happens if this is a true statement. And then we looked at a couple little application problems using geometry that were fairly difficult. Thank you for following along. Toodles.